All right, hello there, algebra students. Mr. Zacek here, and we're in Unit 11. And one of the things that we're going to be doing quite a bit in Unit 11 is factoring. So to begin today, what I want to talk about is some review of factoring. And so the first part here, to factor a polynomial means to express the given polynomial as the product of smaller polynomials. So just as a reminder, before, when we were factoring, if we're using numbers, like we can write 6 as 1 times 6, or we could write it as 2 times 3. So 1 and 6 are factors, 2 and 3 are factors because they multiply together to give you 6. So they multiply back to give you that. So the same thing holds true in polynomials. Now, when we factor, the first thing that we always want to do is find the GCF. Okay, so always look for the GCF first. Always look first for the GCF. All right, in this example that we have, now both of our, so this is what we're looking at here. Both of those have, we got 3 and 9, so the GCF is 3. So now what we do then to get what's inside the parentheses is we divide each of those by 3. So use the GCF in the product. So we got 3 here. Don't forget to write that. That's important. And then it's going to be y plus 3z. Now the reason why y and z are not a part of the GCF is it's not common. In order for it to be in the GCF, it would have to be in both of those. Okay? And so that's find the remaining terms. So this is factored. So the factors, sometimes you'll be asked that, are 3 and y plus 3z because they add together. And you can check that by using the distributive property. If you multiply this back out, it equals 3y plus 9z. So if you do that, it should check for this. All right, so I'm going to do a few of these, and then I'm going to leave you to do the rest of them as part of your own kind of practice work. So, number one, we look here. We're looking for the GCF first. And what do we have common to both? It's the number 2. So this equals 2, and then we divide both of those by 2, and that's just going to be 2 times a plus b. So don't forget to write your GCF in front of that. I'm going to skip number 2 and I'm going to go to number 3. And number 3, well, there's coefficients are 1. Do we have a common variable? We do, and that's b. So our GCF is b. So this is going to equal b, and then you divide both of those by b times the quantity. First one becomes x plus b divided by b is 1. So don't forget that 1. Oftentimes you'll see people that will drop that out. All right, so we got some more, for you to practice here. I'm just going to do maybe 2 more of these. Let's do number 8. Okay, and number 8, what do we see? We've got 15 and 10. Well, what goes into 15? 5, 3. And what goes into 10? 5. So 5 is going to be our GCF. Now there's a C and there's a D, but it isn't in both, so that's not common. So write your GCF, divide by 5, and we're going to be left with 3C minus 2D. So 5 times 3C minus 2D. And again, we could check that by multiplying it back through. All right, and then the last one I want to do is number 12. Now in number 12, what do we have? Well, in both of these we've got the y. So you take the lowest exponent, which is y to the first. So this is going to equal y, and then you divide both of those by y. So in parentheses it will be y minus 3. Okay, so there's your GCF for that one. Okay, we got a couple more here. Let's do number 14. So we're looking for a GCF. 3 and 6. 3 will go into both of those. And now they both have an x, so you pick the lowest power of x, which is x to the first power. So our GCF here is 3x. You divide each of these by 3x. Okay, the first one, the 3's divide, and then we have x minus 2. All right. Now, we can also factor when we have the ABC method here. And so in our trinomials, what we're looking for are what are the factors of A, or what is A, and what are C? 36. So A is 1 and 1. C, 36. We could be 1 and 36, 2 and 18, 3 and 12. Sorry for the announcements. Okay. And 4 and 9, and 6 and 6. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Now I'm looking for, in this one, because this is a plus sign, the ones that add together to be 13. So in this instance, 4 and 9 are what add to be 13. But because this is a negative, they both have to be negative. So it's going to be x minus 4 times the quantity x minus 9. All right, so that's what that equals there. Okay. Now, when you look at one like number 2, what do we have here? Well, we have A as 1, so 1 and 1. C is negative 63. So we've got, now it's going to be negative. So we had a negative 1 and 63. Okay. 2 doesn't go into 63. 3, negative 3 goes into it 21 times. Does 4 go into 63? No, I don't think so. 5 doesn't go into it. 6 goes into it, I believe. No, not 6. 7 goes into it. So negative 7 and 9. Now, again, what we're looking for is, do those add to be B? So negative 7 plus 9 is 2. And that's our B value here, what you see is 2. So that tells me these are going to be x minus 7 and x plus 9. That's going to be our factors. So when this sign here is negative, they have to have different signs as a part of it. Okay. Now I'm going to let you guys practice the other ones, but I want to do one more with you. The last one here, number 10. So A is 1, B is negative 16. So our factors of 1 are 1 and 1, or excuse me, not B, C is negative 16. So we have negative 1 and 16, negative 2 and 8, negative 4 and 4. Well, what's our value of B? There is no B. B is 0. So we need the ones that add to be 0. Well, that's going to be 4 and 4. So this is x minus 4 times x plus 4. So there's a little factoring review just to get you going. It's going to help us a lot here as we look at Unit 11.